Episode 155 of the Rule Your Pool podcast. This is Eric Knight with Orenda and Hassa, and back with me, just like he was last episode, Terry Arko. Welcome back to the show.
Thanks, Eric. Good to be here again with you.
Yeah, thank you. Last episode, I learned a whole lot. In this episode, we're going to do something a little bit simpler. And I know I'm putting you on the spot, but you're kind of the guru on this stuff. We're going to talk about non-chlorine shocks. And in particular, I'm curious about the product that we hear a lot about, which is potassium monopersulfate. So in this episode, 155, I'm hoping we can describe what that does, how it's different from chlorine, and how it should be appropriately used, as opposed to how people misuse it. You ready to go?
Let's go.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Okay, Terry, what is non-chlorine shock and how does it work?
Basically, it's an oxidizer. If somebody's going to go get a product or something that's called non-chlorine shock, it's probably going to say non-chlorine oxidizing shock or non-chlorine shock oxidizer. Okay. It'll have that word on it. And that's a whole EPA thing because it is not a sanitizer or a disinfectant. Perhaps we should start there right away because sometimes there's folks that don't know the difference or that don't know there is a difference.
Yeah, what is the difference?
Something that is a disinfectant, or maybe more familiar in the pool industry, a sanitizer. That is something that is designed to kill living pathogenic, that's disease-causing microorganisms, bacteria, viruses, right, protozoas, those types of things. And that is strictly the role of the disinfectant. When you are disinfecting, you are killing living microorganisms in the water. So now we get to oxidation, and sometimes people confuse those two. Oxidation has to do with the breaking down and removal. So it's not a kill, it's a removal of non-living contaminants like metals and organic material, swimmer waste, oils, soaps, dirt.
This would include nitrogen compounds as well, like urea,
organic nitrogenous compounds.
Okay, so non-living stuff, basically oxidation.
All the non-living waste, which, by the way, the only connection there to sanitizing is that those things can interfere with a halogen, chlorine, bromine's ability to sanitize. So it's important that those things are removed and oxidized in order to get sufficient disinfection or sanitizing.
For the sake of the audience, I would like to expand on what Terry just said. Disinfection and sanitation are often used interchangeably. Technically speaking, disinfection is a 99.999% removal rate within 10 minutes. That's the legal definition. So if you look on a can of household disinfectant like Lysol or 409 or something like that, it will say that on there. To disinfect, like for instance, if I spray Lysol on my phone, I'm supposed to let it sit there for 10 minutes. Does it actually take 10 minutes? Probably not. But legally, it has to say it has to kill 99.999% of pathogens within 10 minutes. That's called a 5-log reduction. That's 5 nines, basically, 99.999. And by the way, disinfection is just harmful pathogens, infectious stuff, right, Terry?
Yep, disease causing.
Right, so sanitation is different, or sanitization is the technical term. That is a 3-log reduction of any living contaminant, whether it's harmful or not. And in swimming pools, the main thing that we're talking about, of course, is algae. Sanitization is a 3-log reduction in 30 seconds. So that is 99.9%. So effectively, if you are disinfecting, you're probably sanitizing too.
Yes.
Okay, because it's a greater level of kill. So the focus is always disinfection because, if algae gets in the pool, it's definitely annoying, but it's not necessarily harmful. What it is it's a symptom that you're not keeping up with your chlorination, and then other things are probably growing too, and that's a really bad sign. If you see algae, address it immediately, get on top of things, be proactive, because you want to make sure that there's enough free available chlorine to handle the the actual harmful stuff that can get us sick. I'm off my soapbox.
Absolutely.
I'm going to turn it back over to you,
Oh,
Terry.
absolutely. That's absolutely correct. And again, as I stated earlier, we have to have sufficient oxidation and we have to deal with all that non-living nitrogenous organic waste, the metals, whatever else there
Right.
is there. And that's kind of where things get twisted, I think, sometimes too.
Well,
Because
hold on. I don't want to derail because you just brought something up that's important for the audience to hear that they probably don't hear a lot of. And you and I have talked about this. Let's talk about affinity. Chlorine has an affinity for certain things, meaning the energy level required for it to interact with that substance is lower than something more complex. So it
right,
has a very high affinity for iron, for instance.
it does.
It will
Uh,
oxidize iron very easily, but it has an even higher affinity for another halogen below it on the periodic table, which would be bromine. And
yes.
when we talked in the bromine episode, sodium bromide, which is something that I'm outspoken against using this in swimming pools because it
Yeah.
doesn't go away,
Right.
that bromide ion is a very attractive target for chlorine oxidation, which creates hypobromous acid, which is a killing agent, but it can't be stabilized by cyanuric acid or anything like that. So it gets used up too and creates bromate. But that's a separate topic. Oxidants can be, depending on what they are, more attractive to chlorine than certain germs. And
Right.
that's the problem. Not all
Right.
of them. I mean,
Right.
sunscreen's a lot more complex, but I'm not a microbiologist, so I don't want to step out over my skis. But from my understanding, Terry, we should be addressing the oxidant demand so that we have less general stuff for chlorine to get bogged down on so that it can focus on these very important things called germs. Am I correct in that?
No, absolutely
I'm
correct.
not correct. You
No, you
said
are.
no.
No, you are correct.
Oh,
Yes.
okay.
Yes, you are correct.
Okay, got it.
Um, I always bring this up when I teach water chemistry classes and when I talk about sanitizers and chlorine and I ask the question, I say, do you know why you're putting chlorine in a swimming pool? Now that sounds kind of ridiculous to ask somebody that, but I get a lot of varying answers. And then I'll get the answer to someone say, oh yes, to kill germs. Right, important. That's your primary purpose. You want to ensure the health of anybody using that pool. In other words,
Right.
you don't want people to get sick from bacteria, germs, viruses, whatever it is. That's why you're putting that chlorine in there. You're putting it in there to disinfect. That's the 5-log kill, which
Mhm.
is great, and if we're killing 5-log, we're probably killing just about everything else,
Yeah.
right? But at the very least, the 3-log, the sanitize, we want to be going after germs. That's our primary purpose. So pool pros or whatever, they're adding it, or operators. And so they're thinking, oh, I'm killing germs. Well, okay, you may not be, because if you have a lot of buildup of this non-living organic and contaminant, a lot of swimmer waste, you're adding that chlorine. The first thing that chlorine is going to do, as you said, the affinity, let's talk about affinity. Its affinity is going to be to go after those non-living contaminants and act as an oxidizer first. The consuming of chlorine through
The
oxidation.
technical term is reduction, because
Okay.
if we look at oxidation from a chemistry perspective, oxidation is the stealing of electrons. We talked about this in a
Right.
previous episode I did on ORP. I'm going to steal the electrons and I'm going to replace it with an oxygen. So
Right.
the killing agent of chlorine in water is HOCl, hypochlorous acid.
Yeah.
I'm going to take the electrons from you, Terry, and I'm going to replace it with my oxygen, and I'm going to become reduced to
Right.
hydrochloric acid, which, by the
Yeah.
way, is what brings the pH back down on a hypochlorite chlorine, which Terry and I have
Yes.
talked about, which is
Yes.
why you get only a temporary rise in pH when you're using liquid chlorine or cal hypo.
Right.
I'm getting reduced because my valence is getting reduced. I'm taking on negatively charged electrons. My valence gets reduced. I get reduced as an oxidizer. So when I oxidize something non-living, I can't keep doing it because I am no longer an active killing form of chlorine. I am reduced into chloride. Correct?
Yeah. That's correct. Now you've just reduced your ability to sanitize.
I've
And you
eliminated it.
yeah, eliminated.
So,
So
what is a non-chlorine shock? I know I mentioned the product potassium monopersulfate. Is that the
right.
only one? Are there others that are used in swimming pools? But I know
There
that's the main one.
there are others. There's one in particular which is called dipersulfate. They all basically do the same thing. They increase oxygen atoms and they, as you said, they decrease electrons, or they take electrons and they exchange that for an oxygen. Chemically, it's basically Well, in a sense, it's a form of a peroxide.
Mhm.
They call it potassium peroxymonopersulfate. There's hydrogen peroxide in there in a sense, in a dry form.
Huh.
It's like about 42 to 43% active.
Wow. Yeah, that's a way more powerful oxidizer than free chlorine
Yeah.
because chlorine is primarily a sanitizer.
Right.
It will oxidize, but it just comparatively, it's not meant to really be an oxidizer. When you compare chlorine to something like ozone, there is no comparison. Ozone is a way more powerful
Right.
oxidizer. Same
Yeah.
with hydroxyl radicals from an AOP
Yes.
system. And a non-chlorine shock is going to be a more powerful oxidizer. So what
Right.
is the appropriate use of this? Because here's the things that I'm seeing. When people use it all the time, they're having issues like calcium sulfate scale. When we've talked about this, because when
Mm,
sulfates
yeah.
get in the pool, and we're talking like weekly or every other week use, they're just throwing this in there because they think it's good for their pool. And usually it's homeowners. Pool pros,
Yeah.
for the most part, aren't having this issue. But it's homeowners like, well, the pool store sold this to me, so I'm putting this in every week as prescribed. And now I've
Yeah.
got these sharp crystals everywhere. It's like,
Yeah.
oh, you
Yeah.
have
Those
very
things
high
are really hard to
sulfates.
get off.
Yeah, well, you can't really get them off. You
Very
have to
hard to
replace
remove.
everything. Yeah.
Yeah.
So we're seeing a high elevation in sulfates. What is the appropriate use?
I mean, I know the directions for monopersulfate are 1 pound per 10,000 gallons. I would start there and I would never go more than a pound per 10,000 gallons. So I wouldn't do the whole more is better thing that people do sometimes, like if it's one, I'm going to throw two in.
Mhm.
Don't need to do that. Don't do that. There's no reason to. The other one is that the directions on these primarily are for weekly use in a pool. Hot tubs, they usually say that after the use of the hot tub, you should add this as an extra method. And again, in a hot tub, you're using very little, a couple ounces, I think, in a hot tub. I think the biggest thing is if you're having to shock, a lot and put a lot of product in, then something else is wrong.
Right.
And that's a problem.
I would think it's really only for a specific thing. And that thing normally is combined chlorine. My understanding, and I don't know who's right on this, Terry, I'm hoping you can settle this because I've seen it published both ways. Some people say that non-chlorine shock cannot remove combined chlorine, but it can remove the nitrogen precursors of combined chlorine by oxidizing them directly. Other people say, well, it can't do the nitrogen precursors, but it will smash combined chlorine. Now, I tend to be in the first camp because it makes more sense to me that you could take nitrogen precursors out than dealing it once it's combined with chlorine, but I actually don't know.
Yeah, I'm going to absolutely agree with you about the precursors. And that's why I say it's very important to oxidize on a regular basis, because hopefully, if you do have a regular sort of regiment maintenance of oxidation to removing precursors, so you're getting less combined chlorine.
Right.
Hopefully, that's the goal,
Well,
right?
if you're chlorinating adequately, you may never need a non-chlorine shock.
Absolutely. If you're maintaining free chlorine always above your combined, in other words, you never allow your combines to get to a place where they're over and above your free chlorine level. You do
That
that, that's it. You're winning.
I think we should do another episode on that because we could explore more. I've definitely done a few episodes on chloramines, but I think you and I could go deeper on that chemistry of what combined chlorine actually
Now,
means.
what I've been told from the makers of MPS, who I've had relationship with,
MPS meaning monopersulfate.
Monopersulfate, potassium monopersulfate. MPS is a really easy way to say that. Is that there's also in the oxidation of the product, or as the product oxidizes it also increases the negative charge of the combined chlorine, and that they can be removed by filtration. I don't know if that's true. I worked with a company, we sold MPS, and that's part of what I was told. I don't know. I don't know if there's
I don't
scientific data or peer-reviewed papers or anything on it. That would be something interesting to look up. I was always told and informed that, number one, it's very good at removing the precursors, and that it does deal with the combines and will remove the combines via filtration. And I do know that I had a gentleman who contacted me and said that he had figured out a way to remove combined chlorines using potassium monopersulfate. And I didn't believe him. And I said, okay, Tell me. And he said, basically what he did was he would add chlorine neutralizer, sodium thiosulfate first,
Mhm.
and knock the chlorine down to 0, and then
Okay.
immediately follow it with potassium monosulfate. And I went and tried this in a couple of pools, and it worked. It worked. We
Interesting.
knocked the combines down to 0 by doing it. And I think theoretically what's happening
It took
is,
the chloride bond away.
first of all, yeah, you're neutralizing all the chlorine out. And then now you just have the organics left behind. You shock those out, and then you can build your free chlorine from there. And I've done it several times and it's worked. And
Wow.
this was just done by a guy who was operating a pool store, and he came up with it on his own and
Well,
called me and told me about it.
if you are going to reduce all of your chlorine with thiosulfate and then put in monopersulfate, that's a lot of sulfate. And
Yes,
I
it
don't think
is.
that's a viable regular
Yeah.
practice. Maybe in a pinch, that makes sense. But if you do that consistently, monitor those sulfates because you don't want calcium sulfate in your
No,
pool.
absolutely. You don't want to build up of sulfates.
But there's clearly a place for this. It is a badass product. There's no doubt about it. It works tremendously well. I don't say the same thing about algicide products. I don't say the same thing about a lot of stuff out there. But there is no doubt potassium monopersulfate does amazing things in the water. I think it should just be used sparingly. That's my take on it.
I agree.
Okay, cool. Well, this has been episode 155 of the Rule Your Pool podcast. Terry Arko, thank you once again for being here and sharing a lot of your wisdom that you've learned
Thanks, Eric.
over at
Always
least
glad
3
to be
years in the
here.
industry.
Yeah, too many, I think. But yeah, glad to be here.
All right, very good. Thank you all for being here. If you have any questions, you know how to reach us, podcast@orendatech.com. Until next time, take care.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.